And here's a little flow chart to help you determine when you're using z-chart, the normal distribution, or if you're using a t-distribution. First question, what is the sample size? So if the sample size is greater than 30, doesn't matter anything else, as long as the sample size is greater than or equal to 30, right away you can use the normal distribution. And because the sample size is large enough, if we don't know what the population standard deviation is, we can approximate it with the sample standard deviation. That's if we know our sample size is large enough. Now, if it's not large enough, you should ask yourself, is the population normally or approximately normally distributed? If it doesn't say it in the problem, you can't assume that it is. So if it's not normally distributed, then there's nothing else we can do. That's the end of the problem. But if it is, that gives us the next question of, is the population standard deviation known? Now, if the population standard deviation is known, then you can use the normal distribution with our z critical values. If the population standard deviation is not known, then we need to use the t critical values with the degrees of freedom. Right. So let's see if we can put that into practice with this question. You randomly select 25 newly constructed houses. So n equals 25. The sample mean construction cost is $181,000. And the population standard deviation is 28,000. Right, assuming construction costs are normally distributed, should we use the normal distribution, the t-distribution, or neither to construct a 95% confidence interval for the population mean construction cost? And then explain our reasoning. So we're going to just take this right to this flow chart. Is n greater than or equal to 30? Our n is 25, so that's a no. We're told in the problem that it is normally distributed, so we follow this arrow down. Are we told the population standard deviation? Yes. So over here, we followed that flow chart and we get to this point where it says we can use the normal distribution. So that is going to be our answer. Use normal distribution. And the reason why we can do that is essentially because it is normally distributed. And we know sigma. Right, that would be the justification enough on a test to show that you really know when you can use certain things. It needs to be normally distributed, and because it's normally distributed, we also know the population standard deviation, and so we're able to use the normal distribution, the z stuff from 6.1 instead of the t stuff from this section.